Hello Junior Rangers, my name is Conservationist Kaye. Today we're going to do a demonstration on ocean currents. This is a demonstration to simulate the ocean's global conveyor on a very, very small scale. We will be observing the density and the temperature of water movement. This is called thermohaline circulation. Okay, to start this demonstration, you start with a large baking pan, and then I have a measuring cup here with 8 cups of warm water in it, and we put about half a cup of salt and 2 or 3 drops of red dye, which will make it a very light pink. So we've got to stir all this up very well, and then we're going to pour it into the baking pan. And while I'm doing that, I want to let you know that this is a bag of frozen water. This is going to be our polar ice cap, and this is our equator. So let's get the water poured in there. Okay. All right. Then we are going to, this is our land mass. We're going to place it upside down in the bowl because currents, of course, have to navigate around all our land masses and everything. So I'm going to have to wait a few minutes before this works. You need to wait until the polar ice cap gets the water a little cold on this end, and it stays warm on this end, and that helps our currents move. Okay, now we're going to drop the blue dye into the cold water and see what happens. Let's see what happens. It should start to circulate around. It's going to bump into our landmass, which naturally occurs, and it should circle to our equator, and it should circle back up. Thermohaline circulation begins in the Earth's polar regions. When the ocean water in these areas get very cold, sea ice forms. When ice forms, salt is left behind. So the surrounding seawater gets saltier, increases in density, and sinks. Surface water is pulled in to replace the sinking water, which in turn eventually becomes cold and salty enough to sink again. A process called downwelling. This is what initiates the deep currents driving the ocean's global conveyor. The cold current moves along until it hits a rise in the ocean floor or land masses, where it is driven up. When this occurs, it is also where the largest concentration of nutrients are found. In those places, you will find your highest concentration of fish and birds. The oceans are huge. Do you know how long it takes for the water to mix over the entire world? It takes 1,000 years. But eventually, yes, it does reach all corners of our Earth. So if one place has pollution, we all have pollution eventually. It takes a while and it seems like a long time, but we put 8 million tons of trash into our oceans every single year. So we have these places called gyres. There's 5 major ones in the world, and there are tons and tons of trash in these. It's where the currents circulate in a circle, and all this accumulates in there. When that plastic, you'd think that we could clean it up, but what happens with that plastic is it breaks down into confetti-like pieces. It's impossible to get out of the ocean. But since it moves in with our food chains, our birds and our fish are also eating that. And it just moves up into the food chain. So guess who eats the fish? Oh, we do. As you can see, it's starting to travel to the equator and make the turn around, and it will go back to our polar ice cap.